I'm John Sasser. I'm with Sabey Data Center Properties. We are in Intergate Quincy in Quincy, Washington. Sabey provides co-location facilities for organizations of varying kinds, government, enterprise, technology. And what we're essentially doing is we're providing large custom buildings that are designed to continuously power, cool, and provide security for our customers' computers. They can be small customers ranging from 100 kilowatts or even as small as a cabinet to large customers over 12 megawatts. And our goal is to make sure that their computers are up all the time and that we are supporting them in a cost-effective means. We use hot aisle containment in our data centers when we cool our servers. And the philosophy there is the air enters the servers. It goes through the servers, picks up heat from the electronic components, exits the servers, and then goes straight back into the air handlers. And what that allows us to do is that allows us to save fan energy. It allows us to deliver a very consistent temperature into the server inlets, and it allows us to deliver higher temperature air to the server inlets. So the air departs the back of the server, it goes into a ceiling return plenum, and then it goes straight back into the air handlers that are up on the roof. So we have multiple air handlers on the roofs of each of our data centers. They're arranged in a redundant fashion. And we found that this actually provides a very reliable solution for us. So we're very concerned about maintaining cooling and efficiency at all times for our data centers. Having multiple discrete units that each actually operate independently allows, if there's a problem with one unit, it doesn't affect the other unit. So the other units just adjust. So if we have to take a unit offline for maintenance, or if it goes offline for some problem, it just takes itself offline. The other units ramp up their fans and we continue the cooling. The computers on the floor really notice no difference. So in Intergate Quincy, we're in Quincy, Washington, which is a very rural area, very heavy agricultural area, and we're amongst fields of various crops. And so farmers, in the course of doing what they need to do, have to plow their fields. That creates dust. In some cases, for a wheat field, they may have to burn their field. And certainly the possibility exists in this part of the country of having area-wide wildfires, which can blanket an area in smoke. And so all of those air quality problems which exist outside the facility are things that we don't want to bring inside the facility. One of the benefits of indirect evaporative cooling in this environment is we have those two separate air streams. We have the inside data center airstream and the outside scavenger airstream. We're never pulling in outside air in order to do cooling, which is different than direct evaporative cooling. In direct evaporative cooling, you're actually pulling in the outside air, and we wanted to avoid that here. We wanted to have those airstreams separate to preserve the air quality inside the data center. So there's the data center airstream, which passes through the inside of an air-to-air heat exchanger, and it just recirculates through there. So it picks up heat in the data center, in the servers. That heat goes then back into the air handler. That air goes through an air-to-air heat exchanger. If it's cool outside or cold outside, and we found that almost 50% of the time it is cool enough outside for this. It's just a dry air-to-air heat exchanger. So you're not adding water, you're not running mechanical refrigeration, it's just a dry air-to-air heat exchanger. If that doesn't get the discharge temperature from the air handler that you're looking at, you have to add moisture. So you add moisture to the scavenger airstream, which again is not coming in contact with the data center airstream, and that brings the temperature down to where it needs to be. So between the dry air-to-air heat exchanger and the evaporative cooling, in our facilities here, we find that 98% of the time, we don't have to run any mechanical cooling. In that 2% of the time, where it's the hottest summer afternoons, we run trim DX cooling that brings it down to the discharge temperature. But we still don't have to run as much DX cooling as you would in a traditional data center air conditioning system. It's just trim DX, so it's 25% of what you would in a traditional air conditioning system, because all the time we're benefiting from that evaporative cooling system. So we've found excellent results from this. Our average annual power utilization effectiveness in our most efficient facility here is 1.13. Ideally, you want it to be 1. That's as low as it can possibly be for the PUE. There's always going to be some inefficiencies, so you want that number to be as close to 1 as possible. 1.13 is an excellent number for data centers. And what it means for our customers is they pay less for electricity. So, between the fact of the efficiency that we deliver here, people might wonder why Quincy, Washington, why an agricultural area for a data center has very inexpensive electricity. So electricity here is 2.5 to 3 cents per kilowatt hour all in, and it has sales tax incentives. It's really probably the most cost-effective place in the country to run a data center if you have the flexibility to run your data center anywhere. And that's why we're here. That's why some very large other data center operators are in this area. Since we don't need as much power, even in our worst circumstances for cooling, we're actually able to downsize generators, downsize switchgear, downsize copper feeders, and spend less money when we're building our data centers. For example, here, we originally planned to use 2 megawatt generators. Instead of using 2 megawatt generators, we were able to downsize it to 1.5 megawatt generators, which saved us money and allows us to provide a more cost-effective facility for our customers. I would say this facility has has exceeded our expectations as it relates to energy efficiency. Back 4 or 5 years ago, when we first started operating the facility, we saw an average annual PUE of 1.18, which is very good. And we saw commissioning PUEs of 1.25 on a hot July afternoon, which again is extremely good for a data center on a hot July afternoon. And what we found after operating in Quincy for over 5 years now is our most efficient facilities are actually operating at an average annual operating PUE of 1.13. That particular facility, I looked at the data just recently, and its average monthly PUE in July was 1.16, which again, in July, it gets in the 90s and hundreds in Quincy. So operating at a PUE of 1.16 for an air-cooled data center in those sort of conditions is extremely efficient. It's much better than 99% of the data centers out there. And to that end, we've received Energy Star certification 3 years running for Building C with a rating of 100, which is the highest rating you can get from Energy Star under its data center program. In 2016, Sabey Data Centers achieved our goal under the Better Buildings Challenge that Department of Energy sponsors. And in the recent Better Buildings Summit, they provided material which shows that we improved our energy efficiency more than any other data center participant that's participating in this. And certainly the air handlers that Munters provides is a part of that. We actually went and invented and patented a testing device which tests airflow in a data center. Whenever we build a data center and commission that data center, not only are we testing to make sure that we can power and cool the load within that facility, but we're also testing to make sure that we can move the necessary air. And sometimes people don't realize that they don't have as much airflow as they think they have because they don't test it. And very often the customer load doesn't really test the limits of the facility. We test at 100% airflow that our air handlers can move the amount of air that they're designed to move. And that's why we have such confidence in our ability to cool high density loads. As long as the IT equipment can move the air through the server, then the facility can take the air and move it as needed through the air handlers. So I'd like to introduce Ryan Beebout, who is our operations manager for the site. Ryan has been extremely involved in operating these units and the entire site, and dealing with issues like water quality and scaling and all the issues, and does an extraordinary job of optimizing these sites and running them very efficiently and very reliably for our customers. So we're very pleased by the abilities of Ryan and his team here on the site to operate these designs optimally so that our clients' needs are met.
I'm Ryan Beebout. I am the operations manager for Sabeys Intergate Quincy campus here in Quincy, Washington. I manage the facilities team that is responsible for operating our electrical and mechanical infrastructure and maintaining that equipment. We work very closely with the Munters Indirect evaporative cooling air handlers on a daily basis, and we perform maintenance on them, and we operate them, and we keep everything running. The water that is delivered to our site is groundwater, and it is very hard water. It has very high concentrations of total dissolved solids and very high concentrations of silica. This is not ideal for use with evaporative cooling, but what we found with the Munters polymer heat exchanger is that they hold up very well to this hard water. We operate at about 2.5 to 3 cycles of concentration in our sumps, which is really pretty good considering the poor water quality that we're dealing with. We also treat the makeup water with a chemical descaler that reduces the rate that minerals deposit themselves onto heat exchanger surfaces. And we treat the water with a chemical biocide that eliminates algae formation in the sumps, and it also reduces the risks of Legionnaire's disease. Despite the use of the chemical descaler, there is still some minerals accumulation that occurs on the heat exchanger tubes. But what we found, to our delight, is that the Munters heat exchangers do a great job of shedding that accumulated minerals, and in that sense they basically clean themselves. We found that with other units that we operate here in Quincy that are utilizing an aluminum heat exchanger, that mechanism does not occur. And with aluminum heat exchangers, we don't see the mineral deposits breaking up on their own and falling into the sump like they do with the Munters polymer heat exchanger. We've been operating Munters indirect evaporative cooling units here in Quincy for over 6 years, and we have never seen any degradation in heat exchanger performance due to scaling. While we don't have to actively clean the heat exchangers themselves, we do have to clean the sumps periodically. We do this about once a month per unit, and this is to remove any debris, dirt, or scaling that is collected in the sump over time. And once a month doesn't sound like a lot, but because we operate so many Munters indirect evaporative cooling units here in Quincy, we do spend a considerable amount of man-hours cleaning sumps. And one of the benefits of using a Munters IDEC unit is that the sumps are so open and spacious and accessible. They're just easier to clean than some of their competitors' units. And we found that this significantly reduces the amount of time it takes to clean a sump. Very often, data centers operate at IT loads that are lower or even significantly lower than the design IT load capacity. We call this part load. We found that the Munters indirect evaporative cooling units operate very well in such conditions. With their motorized dampers and IEC scavenger fans, they're able to really dial in the discharge air temperature to the set point that we want it at, and they do so very efficiently. In all of our partly loaded data centers, the annualized PUE is less than 1.2. We have experienced both summers and winters here in Quincy that have exceeded the design outside air conditions, and what we found in those conditions is that the Munters units are able to maintain the temperature inside the data hall well within the bounds of our service level agreements. Obviously, that exceeds our expectations, and needless to say, we're very pleased with that. The mechanical contractor, the controls contractor, and Munters all work very closely with one another in concert to deliver a building automation system that is both reliable and robust and very easy to operate. The building automation system that we use here in Quincy is automated logic. It was custom built by our controls contractor, Sunbelt Controls, and it interfaces with the Munters iDeck units. We use the building automation system to operate the unit automatically. We use it to take manual control in those situations that we need manual control, which are infrequent. And we use the building automation system to monitor all the parameters of the iDeck unit and the data hall, and to send alarms to the staff if any parameter goes outside of its limits. I've worked with other systems, including direct evaporative cooling, and I found that direct evaporative cooling can sometimes have a negative effect on humidity in the space that you're trying to control. So I really like indirect evaporative cooling because for the most part it has a minimal effect on humidity, if any at all. When I take people on tours of our data halls, I really enjoy it when they tell me how clean everything is. And that is in part due to the indirect evaporative cooling units not bringing in outside air into the data hall. The Munters air handlers have an exceptional build quality, greater than some other competitor units that I've seen and worked with. The quality of their components is top-notch. The work that they do in the factory is very, very good. They obviously pay a close attention to detail. Everything from the wiring and the controls panels to the paneling themselves, the doors, everything is of great quality. We did have one issue with the components in our Munters iDeck units, and that was with the sump pump. Early on we had a string of pump failures, probably due to our water quality issues. And Munters did a great job working with our mechanical contractor McKinstry to replace pumps that had failed under warranty and provide us with lots of extra ones for spares while we were going through this issue, and coming up with a different, better solution to our problem. In terms of performance, maintainability, and operability, we found that the Munters indirect evaporative cooling units have exceeded our expectations, and we are very happy with them.
We found that the Munters air handlers that we put on our facility meet or exceed all of our expectations, and that's put a lot of faith that I have for Munters and their ability to engineer quality products and build quality products. I know Munters is in the business of building custom air handling solutions for a variety of different purposes, and when we look at a new product in the data center industry, very often we look at it skeptically because, you know, if it's something that hasn't been built and it's not in operation, we're not very sure that it's going to work. With Munters and their many years of experience, with our experience with them, we have a lot of faith that if they design something, that product will operate as intended. And we're still going to test it. You know, we always test it. You know, it's the old trust but verify thing. So we'll test it, the airflow, in our data centers with our mobile commissioning assistants. But we've never found an instant where Munters has failed to deliver in design airflow in the performance of their units. Now, we've been running these units for over 5 years now, and there's always going to be a problem here or there, you know, something that breaks and support that we need from the factory. And every time that we've sought that support, it's been there. So Munters has been very responsive. They've helped us solve problems that were unanticipated that occurred in the field, and we've been very happy with that relationship.